In the previous lesson, we focused on the big picture. In this lesson, we're going to look at another aspect of a word problem, the details. The details in the problem include the given values and the unknown values. These are the items that we must deal with in the second and third steps of solving a word problem. In step 2, we identify the meaning of the given values in the problem. And in step 3, we identify the problem requirements, which are the unknown values we need to find to solve the problem. Let's see how to do it in practice, using the following example. We start by defining the big picture. In this problem, the car, which is the object, travels over a certain distance. The speed, travel duration, and the distance traveled are attributes associated with the car object. After we understand the situation, let's move on to the given details. The way to analyze the given details is by going over each value in the problem and identifying its purpose using a data item. "32 miles per hour is the speed of the car, and 6 hours is the travel duration of the car." This step will be complete after we identify the purpose of all the values given. What's missing is an identifier for every data item. Now, let's analyze the requirements. A requirement in a word problem usually appears in one of two ways: as a question, as we can see here, or as an instruction, as shown here. Either way, we need to specify the requirement as a data item. We can do it this way: the distance traveled by the car. As you can see, this data item contains an attribute, the distance traveled, and an object, which is the car. Let's see another example. Pause the video and take time to read the problem and specify the big picture. We assume that the objects are the store, the mini robot, and the learning tablet. Now let's see the attributes of each object. The store has these attributes: planned number of mini robots, planned number of learning tablets, actual number of mini robots, actual number of learning tablets, and total budget. The mini robots and the learning tablets have these attributes: original price and actual price. We can see that all these three entities, the store, the mini robots, and the learning tablets, have attributes in the problem. So they can all be considered objects. Now let's define what's going on in the problem. A toy store planned to buy stock of mini robots and learning tablets with a certain budget. Since the price of the products increased, the store updated the quantities of each product, so the total price would match their budget. Now let's do step 2 and define the given values. We can specify the given values, as we did up until now, using data items. However, that involves a lot of writing. Instead, we can use the table we developed earlier to specify what each value means. Each row in this table contains both an object and an attribute. We can add the relevant value and label and have a complete description of the data item. Now it's time to specify the requirements. The requirements in this problem are the original prices of the mini robots and learning tablets. We can use a table to specify these requirements. By using a table, we can easily represent relationships between the values in the problem. For example, the actual price of a mini robot is greater than its original price by $5. We can represent this relationship in the table as follows. If R is the original price of the robot, then R plus 5 would be the actual price of the robot. The same principle applies to the price of the tablet as well. The key to successfully understanding the given details and the requirements in a problem is to correctly identify the objects and attributes in the problem and use them to break the problem up into simple pieces, thus giving it a clearer structure, however complex the problem is. Having done this, we are ready to move on to the last part of the process, developing the solution. We will talk about this step in the next lesson. In this lesson, we learned how to step forward from the big picture to analyze the given details and the requirements in a problem. The key points to remember are: all word problems contain numerical values. A numerical value may be known or unknown. In the second step of the process, we must analyze what the known values mean. In the third step of the process, we identify the requirements in the problem. A problem requirement is the value we need to come up with an answer to the problem. Now it's time to practice what we've learned. In the following problems, specify what the given values mean and the requirements. Don't forget to define the big picture first and use the objects and attributes as shown in this lecture. A downloadable PDF that contains this assignment, as well as answers, is waiting for you in the resources area.